The base is bounded by the circle x squared plus y squared equals 4 with cross sections that are isosceles triangles. And I went back and added this wording. I forgot to have it on your notes, with a leg in the base perpendicular to the x-axis, because if you have isosceles triangles, there are two different ways they can be oriented. Think about an isosceles triangle. The two legs have the same length, and then you have your hypotenuse. Well, if you're talking about how to orient these triangles on this circle, we could either put it where the hypotenuse is on the base of this circle, and the two legs are sticking up in the air, and the point between the two legs is on the top. Or, this is usually how they phrase it, with a leg in the base. So it has one of its legs that's the same length that's sitting on the circle. The other leg is sitting up in the air, and then your hypotenuse would actually be, so if you can kind of visualize this, here's one of your legs. Let's just say, for example, right here, that's one of the legs. The other leg is sticking straight up out at you, and then the hypotenuse is going from this point to the other point right there. You can kind of visualize that. All right, so our first step is we have to figure out our area formula. So let's start with the basics. We're talking about a triangle. So area of a triangle is 1/2 times the base times the height. So let's think about this. The base is the distance from one side of the circle to the other. Okay, that would be a base. This would be a base right here. We would have a base going from -2 to +2. Okay, those would all be bases that are in that are on the curve here. Okay, so that's our base. Because of the way that they told us it's oriented, if a leg is in the base and it's isosceles triangle, the height of this triangle is the same as the base. The height of the triangle is the same as the base because here's one leg, the congruent leg is sticking straight up in the air, and that's your height. So really, our area formula here doesn't have two different variables. The base and the height are the same. So really, it's base times 1/2. Okay, because it's an isosceles triangle, the base of the triangle is the same as the height of the triangle. Your triangles look like, if we looked at it from the side, this is what our triangles are looking like. This is the base, this is the height, but they have the same measurement. So we need to come up with an expression for the base. And if you want to, you can write that as base squared. Base times base is base squared. We need to come up with an expression for that base that is related to our curve, because that's what's dictating the base. The base is not always the same length. It depends on where it is in this circle. So let's go to the equation of our circle here. We've got x squared plus y squared is equal to 4. Now, since our cross sections are perpendicular to the x-axis, we need to write that equation so that it is solved for y. We need it in terms of x, meaning that it's solved for y. So we subtract the x squared, and we take the square root. Technically, it's the positive and the negative. This top curve right here is the positive square root of 4 minus x squared, and no, that is not equal to 2 minus x. 2 minus x is a line, it's not a curve. This bottom part is negative 4 minus x squared. Okay, so if we think about it, this half of the base is equal to the y value, right? The y value is given by the equation. This other half of the base, is it the same length or is it differently? Is this in green the same as what I have in blue? Is that the same distance? Yes, it's just in opposite directions, but it's the same distance. So my base is, the easy way to write it would be 2 times the square root of 4 minus x squared. Because the square root of 4 minus x squared is that blue segment. Y'all told me that the green segment's the same thing, so it's just 2 times that. Okay, good question. Can we have negative area? Well, ultimately, we're talking about volume. So, no, it's always going to end up being positive because we're talking about volume. Volume will never be negative. Volume should never be negative. Yeah, volume should never be negative. Okay. Any questions about what I've constructed so far? Does that make sense? Let's simplify this expression first, because if we can simplify it before we integrate, that's going to be a lot easier on us, right? So if we apply that squared to what we have in parentheses, 2 squared is 4. Squaring a square root cancels the square root. And then 1/2 times 4 is simply 2. And go ahead and distribute that 2. 8 minus 2x squared. So that should give us, that formula right there should give us the area of all of our triangles. Depending on where we are in the circle, that will give us the area of our triangles. Now, if you want to check, I think it's a good thing before you start integrating to check and make sure that it works. Pick one that's easy. Like in this case, where x equals 0, I can very obviously tell that the base of my triangle here would be 4. So if I plug that in, if I plug in 0 in my area formula, it says that the area of my triangle should be 8. Well, let's test it out. If I'm testing the area of this triangle, it would be 1/2 times its base is 4, and its height is 4, because the base and the height are the same, because it's an isosceles triangle. That gives me an area of 8. So that's just checking to make sure that I came up with the right area formula before I put it in my integral. So my volume is going to be the integral from my starting point, -2, to +2, of all the areas of my triangles. 8 minus 2x squared. So we integrate. It gives us 8x minus 2x cubed over 3. Evaluated from -2 to +2. So if we plug this in, we get 16 minus 2 cubed is 8 times 2 is 16 over 3. Minus, plug in a -2, so -16. And that would give us +16 over 3. Be careful with these, because right now it kind of looks like things cancel, but remember, you're subtracting, so change those signs and add, so we actually get 16 plus 16, which is 32, and -16 thirds plus -16 thirds, which is -32 thirds. And if we get a common denominator, that's 96 over 3 minus 32 over 3, which gives us 64 over 3. Any questions about that? Okay, let's look at one that's in terms of y. The cross sections are perpendicular to the y-axis. So they give us a figure here whose base is the region between the inverted parabola, y equals 4 minus x squared. They call it inverted because it's a downward facing parabola because it's negative x squared. And the x-axis, whose vertical cross-sections perpendicular to the y-axis are semicircles. So they actually give you a picture of this one. It makes it a little bit easier, but there's still things that we need to figure out. Okay, so our area formula, we're talking about a semicircle, so area equals 1/2 pi r squared. So the radius, and they explain this a little bit more so you can see it, but this time we are perpendicular to the y-axis, so we need to take that equation that's solved for y, and we actually need to solve it for x. Now, they've already done it, but I want to show you the steps, just in case. Personally, I would move the x squared over to make it positive, and then subtract the y over. So add the x squared, subtract the y, and then take the square root. So x is equal to the square root of 4 minus y. So that's where they get that equation that they're using there. Again, the positive one would be the curve on the top, the negative one would be the curve on the bottom, similar to the circle problem that we just did. All right, so that means that the radius right here of the semicircle, that radius is equal to your x-coordinate over here. And you can see that in the picture where they take away the three-dimensional figure. Here's the radius of one of the semicircles. And if you think about it, that's the same distance right here. Well, that's your x-coordinate. Your x-coordinate is equal to the square root of 4 minus y. So that's our radius. So let's plug that in right over here. And once again, simplify. 1/2 pi, squaring a square root cancels. And I would distribute that 1/2 pi. So that gives us 2 pi minus pi over 2 times y. 1/2 pi times 4 is 2 pi. 1/2 pi times negative y is negative pi over 2y. Okay, so that's our area formula. So let's set up our volume expression. Our volume is the integral from, this time it's in terms of y. So we're starting at the x-axis over here, and we're ending at the top of this parabola. Now, they've already worked it out for you, but that would be from 0 to 4 of our area formula. And this one is with respect to y. Our variable is y, our limits are y values. Now, it doesn't really change the way you integrate, except you're supposed to use a y instead of an x. So when we integrate, that's 2 pi y minus pi over 2 is just a constant multiple. The antiderivative of y is y squared over 2. We're evaluating that from 0 to 4. So when we plug in the 4, we get 8 pi minus 4 squared over 4, which is 4 times pi. When we plug in 0, both of those terms have y's in them, so it's going to cancel. So 4 pi is our volume.